Good morning, students. Today we are going to read alkanes in the topic of organic chemistry. This is very important and tricky topic, technical topic. So you have to concentrate very well. So concentrate yourself, student. This is very important topic. Rather, this is the most tough topic in the chemistry O level. So we are going to start now. Alkanes. The general formula of an alkane is CnH2n plus 2, where N stands for 1, 2, 3, and up to so on. Alkanes are very good fuels, reacting well with oxygen. They also react with chlorine, but otherwise they are very unreactive. One reason for this is that there are no spare bonds in an alkane chain. Very important point, students. Each carbon in the chain has as many hydrogen bonded onto it as possible. The compound is said to be saturated. They are a homologous series. Each member differs from the next by a CH2 group. Members of the homologous series have. So this is a short question which normally comes in the paper of 2 or 3 marks. What are the properties of the homologous series? So members of the homologous series have the same general formula, similar chemical properties, different melting and boiling points, such as the melting and boiling points increase as the number of the carbon atom increases. They can be made by similar methods. They differ in physical properties due to different number of the carbon atoms in each compound. The greater the number of the carbon atoms, the greater the intermolecular forces of the attraction. Hence, the more difficult it gets to break the molecules apart. More heat energy is needed for such a purpose. Alkanes are a family of saturated hydrocarbons. They only contain carbon-carbon single bonds. This is carbon-carbon single bond. Table below shows the first 4 members of the alkane family. Methane. Molecular formula is CH4. Structural formula will be C will be placed here, and with single bonds H will be attached. Ethane. C to H6. So CC will be attached with carbon with single bonds, and on the sides H atoms will be attached with these single bonds. Propane. Formula is C3H8. So propane stands for 3 carbon atoms. So 3 carbon atoms will be attached with single bonds, and on the sides hydrogen atoms will be attached with single bonds. Butane. Chemical formula is C4H10, and structural formula will be 4 carbon atoms will be attached with single bonds, and on the sides single bonds will be with the H atoms. Next members are pentane, C5H12, hexane, C6H14, heptane, C7H16, octane, C8H18, nonane, C9H20, and decane, C10H22, and so on. And this is the covalent bonds in methane and ethane. As alkanes are covalent compounds, they have low boiling points. Most alkanes are gases or liquids at room temperature. And these are the diagrammatically representation of the covalent bonds. This is methane and this is ethane. Here is a question now. When must a substance be an alkane? Answer is C part. When it has the general formula CnH2n plus 2. This is the general formula of the alkane. The homologous series of the alkanes has the general formula CnH2n plus 2. A, B and D are all properties of the alkanes, but A and B are also applicable to alkenes. Its property is when it burns easily in air or in oxygen. This is the property of the alkane, but of the alkene as well. B is when it contains carbon and hydrogen only. Okay, this is applicable to alkanes, but this is applicable to alkenes also. And D, when it is generally unreactive. Okay, but C's part is the most solid option for the question because this is the general formula of the alkane. There is no doubt at all now. Butane has two isomers. And the definition of the isomers is isomers are molecules which have the same molecular formula but different structural formula. Isomers of the same homologous series have the same chemical properties but different physical properties. The isomers of the butane are shown below. And these are the isomers of butane. The name of the second isomer above is 2-methyl propane. So this is not propane. Okay, this is 2-methyl propane, but this is butane. Okay, these are the isomers of the butane. The method to read the formula of this kind of structure is we have to start counting from the side from where the functional group will be near. Here is the functional group, that is CH3. Functional group is attached to the central carbon atom, that is at equal distance from both sides. So we can start counting from both sides. So if we start counting from right side, so this is the second carbon atom to which CH3 group is attached, that is methyl group. So we will count 1, 2, so 2 methyl, and there are 1, 2, 3 carbon atoms now, so propane. So 1, 2, 2 methyl, 1, 2, 3 propane. So the name is 2-methyl propane of this structure. Butane gas is commonly used as bottled gas for cooking. Very important question as far as MCQs are concerned. Carbon dioxide and steam, plentiful supply of the air. Also carbon soot and carbon monoxide in a limited supply of the air. And this is the butane gas that is contained in the camping gas. So when this gas is burned in plentiful amount of the oxygen, carbon dioxide and steam will be produced. But when this gas is burned in a limited supply of the oxygen, soot and carbon monoxide will be produced. Isomerism is essential in the petroleum industry. For example, car engines do not run smoothly on a straight chain octane compound, but is better when burning a branch chain isomer as in trimethyl pentane. In the past, lead compounds were added to make cars run more smoothly, but this caused pollution to the environment. Hence, more branched chain alkanes are now used to smoothen the running of the car engines. Although more costly, this reduces the pollution. Here is another question. The structure of the two compounds are shown. So 1, 2, 3, 4. So this is butane. So these are actually isomers of the butane. This is 2-methyl propane and this formula is butane. The compound have the same. Answer is C part. The two diagrams are the isomers of the butane. Isomers have the same molecular formula, hence they have the same percentage composition. So because they have the same molecular formula, so percentage composition by mass is same. This is the key point for you people. Isomers are organic compounds that have the same molecular formula but different structural formula. Because of the difference in these structures, physical properties such as melting points and boiling points are also different. Another question is here. Methane is used as a fuel. What property is essential for this use? The answer is A. It burns exothermically because heat is given out. So it is used as a fuel because heat is given out. This is very important property for a fuel. Fuel is not necessarily a gas. It can also be a solid, as in coal. A fuel is a substance that can burn in air or oxygen and give out heat energy. Physical properties of the alkanes. When we descend the alkane homologous series, the number of the carbon atoms increases. The molecular mass increases. The molecular size increases. The intermolecular forces of the attraction increases because of the increasing number of the carbon atoms. This results in gradual change in physical properties. Melting and boiling points increases as we go down the homologous series. Viscosities increases. Densities increases. Flammability decreases. Flammability decreases because of the more carbon atoms require more heat energy to burn. Chemical properties of the alkanes. Alkanes are saturated hydrocarbons. Alkanes are unreactive. Alkanes do not react with acids, alkalis, or oxidizing agents. Alkanes undergo substitution reactions. A substitution reaction is a reaction in which an atom or a group of atoms is replaced by another atom or group of atoms. Combustion of the alkanes. Alkanes burn completely in oxygen to form carbon dioxide and water. So methane reacts with plentiful oxygen, forms carbon dioxide and water. Propane burns in plentiful oxygen to give out carbon dioxide and water. So you have to practice these reactions and again and again by writing, because there is no spare time, there is no extra time, there is not much time in the paper. So you must be able enough to write the reactions in very smooth way. So practice these reactions by writing again and again. Incomplete combustion produces carbon monoxide and also soot. So when methane burns in limited supply of the oxygen, forms carbon monoxide and soot. And other reaction is methane burns in limited supply of the oxygen, burns soot and carbon monoxide. Substitution reactions of the alkanes. Alkanes react with halogens to form halogen alkanes. These are substitution reactions. A substitution reaction is a reaction in which one or more atoms of an organic compound are replaced with one or more other atoms. This is the definition of the substitution reaction. Alkanes react with chlorine in the presence of the sunlight, in which their hydrogen atoms are substituted by chlorine atoms. Methane react with chlorine to produce four substitution products. In the first stage, when methane is reacted with chlorine, one hydrogen atoms will be replaced by one chlorine atom and it will form chloromethane, and with it HCl will be produced. On the second stage, when this chloroform will be reacted with chlorine and other hydrogen atoms will be replaced by another chlorine atom, so the product will be CH2Cl2. The formula, the name is dichloromethane, and again with it HCl will be produced. In the third stage, this dichloromethane will be reacted with the chlorine atom and chlorine, and other hydrogen atom will be replaced by another chlorine atom and the product will be CHCl3. This is trichloromethane, and with it HCl will be produced. On the fourth stage, trichloromethane will further react with chlorine and other hydrogen atom will be replaced and other carbon atom, chlorine atom will be added, and the product will be CCl4, that is tetrachloromethane, and with it HCl will be produced. I'm telling you again, you have to practice these reactions by writing again and again. So you should have grip on the reactions, because there is not much time in the paper to think, to balance the equations. So you should be able enough to write the equations in a smooth way in the paper. So practice it at home, because you have the time now for practicing. Many chloroalkanes are important solvents. This is again very important question. Tetrachloromethane, that is CCl4, was used for a long time by the dry cleaning industry. Trichloromethane, that is CHCl3, is better known as chloroform, the anesthetic that is used in the hospitals normally. Fluorohydrocarbons, hydrocarbons which contain fluorine, is called fluorohydrocarbon, or another name for it is freons for short. The solvents in the aerosol sprays and the liquids which circulate in a refrigerator are freons. So these are the uses of the freons. These are used as a solvent in aerosol sprays and as a liquid that circulate in the refrigerator. Another question is here, octane is an alkane present in petrol. What are the products when octane is completely burnt in air? So when completely burnt in air, it means plentiful supply of the oxygen is available. So B option will be the right one. Carbon dioxide and water will be produced. So B, octane undergoes combustion reactions to give carbon dioxide and water in plentiful supply of the oxygen. Exam tip is, when incomplete combustion takes place, carbon monoxide and carbon soot may also be formed as pollutants, as insufficient oxygen is provided for complete combustion. Next topic in the lecture is cracking of a big alkane molecule. Petroleum or crude oil is mainly made up of a mixture of the hydrocarbons. Most of these hydrocarbons are big molecules. Cracking is essential as smaller molecules are required in large amounts as fuel for motor vehicles. Cracking is done by passing vaporized oil over a solid catalyst, where the big molecules break upon the surface of the catalyst to produce a large mixture of oil molecules. This is the process of the cracking. There are essentially three uses of the cracking. And other very important short question. Three uses of the cracking. They are to break up large hydrocarbon molecules into smaller ones to produce fuel for the motor vehicles. This is the first very important use of the cracking. The second use is it is a means for producing alkenes. So when alkanes are cracked, alkenes are produced. Here are some examples. A lot of ethene is produced in this manner. Ethene is useful in the manufacture of the ethanol and plastics such as polythene. So these are the uses of the ethene. And the third use of the cracking of the alkanes is cracking is also means of producing hydrogen gas. So when alkanes are cracked, hydrogen gas is produced. Cracking is important for two reasons. It turns the less useful fractions of the oil into more widely used shorter chain compounds like petrol and kerosene. The second importance of the cracking is it produces unsaturated hydrocarbons like ethene. These are more reactive than saturated hydrocarbons. Ethene is the starting material for many important manufactured substances such as plastics and methylated spirit. Another important question for you people is, why are large alkane molecules cracked to form smaller molecules? They are cracked into smaller molecules because they are in high demand. So, the answer is D part, to meet the demand of the small alkane molecules. Smaller alkane molecules are in higher demand. Exam tip for you people is, large alkanes are usually solids and are heavy and bulky. They are less useful. That's why they are cracked into smaller chains. So this was the topic, students. Hopefully that will be very useful for you people in the exams. Read this lecture again and make your notes. Thank you so much.